If your last debugging session was change the code, run it, hope you weren't debugging. You were guessing. Here's the shift this video is about. Stop guessing what might be wrong. Start forming ideas you can prove false fast. Here's what you'll walk away with. Why trial and error feels productive but isn't. What a falsifiable hypothesis really is. How to test one thing at a time. And a framework you can run even when you're under pressure to ship fast. Changing code and rerunning it feels like progress. Your hands are moving. The terminal is busy. But feeling busy is not the same as learning something new about the bug. Say you change 5 things in a row. The bug might disappear, but you still don't know why. When it comes back, you're starting from zero again. The fix is simple to say, harder to do under pressure. Before you change a single line, write one sentence. This is what I think is happening, and here's why. Trial and error costs you 3 things. You lose track of what you already tried. A bug that disappears might just be coincidence. And you learn nothing you can reuse the next time a similar bug shows up. In science, a hypothesis is only useful if it can be proven wrong. Debugging works the same way. If you can't imagine a test that would prove your idea false, it isn't a real hypothesis yet. Falsifiable just means one thing. There's a clear test that could prove the idea wrong. Something is wrong with the database, can't be tested directly. The query returns null for a user with 0 orders can. You run it and you check. Look at the difference. The guessing log has no reasoning, just a list of things tried. The disciplined log states one hypothesis, one test, one result. Hand that second log to a teammate and they'd know exactly where you are. Before you write any code, ask yourself one question. What result would prove me wrong? If you can't answer that, your hypothesis is still too vague to test. Once you have a hypothesis, the next mistake is testing it badly. The most common way, changing several things at once. Say the bug disappears after you change the config, the code, and restarted the service all at once. It's fixed, but you don't know which change mattered. Next time, you're guessing again. Test one variable at a time. Change the config, run the test, note the result. Then and only then move to the next change. It feels slower. It's actually faster because every result teaches you something certain. This isn't an absolute rule. If restarting your local server costs nothing, batching a few changes is fine. But the higher the cost of guessing wrong, like a production deploy, the more strictly you should isolate each variable. This is the part that actually solves the guessing problem. A 4-step loop you can run even when your manager is asking for an ETA. 4 steps in order. Observe exactly what's failing and when. Hypothesize one falsifiable reason. Test it with the smallest check that could prove you wrong. Then decide. Confirmed, move forward. Falsified, form a new hypothesis and go again. It feels backwards, but writing down a hypothesis before touching code is faster overall. 20 random changes over 2 hours can leave you no closer to the cause. 4 disciplined hypotheses can close the same bug in 25 minutes with an answer you actually trust. Here's the loop on a real example. Checkout fails only when the cart is empty. Hypothesis. The total function throws on an empty cart. Test it directly in isolation. It throws. Hypothesis confirmed. Fix it, then retest that exact case to confirm the fix worked. When you're being watched, or the clock is running, the pull to just start changing things gets strong. That's exactly when one written hypothesis saves you the most time. Every debugging session comes down to one of these 2 approaches. Random changes burn time and leave you with no certainty. A stated hypothesis and a targeted test give you a real answer every time. So to recap, state one falsifiable hypothesis before you touch anything. Change one variable per test. Run the same 4-step loop even when you're under pressure. And treat every result as something that teaches you, whether it confirms your idea or kills it. If this changes how you approach the next bug, subscribe. Every video here breaks down one thing senior engineers do differently, and how you can start doing it too.